Complex numbers means we are working with the imaginary unit I. I, by definition, is the square root of -1. So that means when we square I, so I squared would equal -1. It undoes the radical. Now, complex numbers are the form a plus bi. A is the real part, bi is the complex part, and we can actually graph those on the complex plane. It's just instead of an xy axis, we have the x-axis is the real axis and the y-axis is the imaginary axis. And we can figure out magnitude, that's the distance it is from the origin, and that's just working with Pythagorean theorem, figuring out the horizontal distance, the distance from the origin on the real axis squared, plus the distance from the origin to the vertical part squared. So basically it's just right triangle, finding the hypotenuse. And we've got some examples working with that. Our first one, we want to graph -6 minus 3i. So we go to -6 on the 1, 2, 3, 4, 5, -6, and then plus or minus 3i, 1, 2, 3, our dot would end up right here. Because we take the real part as the x value of the ordered pair, we take the imaginary, the number that's with I, as the y value, and then we just plot the point. Okay. Now magnitude, 4 minus 5i, we're going to take the 4 and square it. We're going to take the -5 and square it. 4 squared is 16, -5 squared is positive 25. Add them together, that gets you 41. So the magnitude of the number 4 minus 5i is square root of 41. So its distance from the origin to that point is the square root of 41. Now we also like to work excuse me, with powers of I. I to the first is just I squared by definition is -1. Now I to the third, we can break that apart into the previous two, I squared times I. We know I squared is -1 and I is just I, so that's -1 times I, or -I. I to the fourth, well that's just I squared squared, so that's -1 squared, which is +1. Right here, I, -1, -I, and 1 are the only four possible answers when we take I to a power. So I to the 10th, that is just I squared to the 5th power, and I squared is -1, -1 to the 5th power, that's going to be a -1. And then we can add them or subtract them. Adding and subtracting, we just treat I like it's a variable. When we multiply, we have to remember I squared is -1. So 13 plus 6i minus 4 minus 8i, we put the 13 plus 6i outside of the parentheses, and then we distribute that subtraction to everything inside, so -4 and -8 turns into plus 8i. 13 and 4 are like terms, 13 minus 4 is 9, 6i plus 8i are like terms, 6 and 8 is 14. So 9 plus 14i would be our end answer. Multiplying, we have to take the 6 times everything, so 6 times 4, 6 times -5i, and then the 3i times 4 and the 3i times -5i. Gets us 24 minus 30i for the 6 times everything in the second set of parentheses. 3i times 4 is 12i, 3i times -5i, well 3 times -5 is -15, I times I is I squared. Right here we got to remember the I squared is -1. But we can combine these two in the middle. -30i plus 12i is -18i. -15 times -1 is going to be plus 15, so 24 plus 15 is 39. So our end answer is 39 minus 18i. Now multiplying, we like to work with what's called a conjugate. Here we have 4 plus 5i. Its conjugate is just 4 minus 5i. A conjugate is the exact same terms, but instead of addition in the middle, it's subtraction, or instead of subtraction, it's addition. So we take the top and bottom times 4 minus 5i, and we need to distribute that top and bottom. 2 times 4 gets us 8, 2 times -5i gets us -10i, and then -3i times 4 gets us -12i, -3i times -5i gets us plus 15i squared. On the bottom, 4 times 4 gets us 16, 4 times -5i gets us -20i, 5i times 4 gets us plus 20i. If you notice, those middle two are going to cancel out. 5i times negative 5i gets us negative 25i squared. The I squared is going to turn that minus 25 into a plus 25 because I squared is negative 1. On top, that's going to have us 8 minus 22i minus 15. 8 minus 15 is negative 7, and then 16 plus 25 on the bottom is 41. That would be our end answer. And then practice. Try them out. Show me your work as you are working through these, and we'll check them.